pen. I kind of just realized there's no note in here, but it's very quiet.
I know, it's dead in here.
Well, she's lucky enough. I got the blackboard after work. You did?
Yes.
That's how I got her announcement in the class. You have to go in.
Mine's been working the whole time.
Okay, mine did not work forever.
Yeah, my app is like off and on. I don't.
It used to kind of involve in the app, but not really.
You have to like, as stupid as it sounds, you have to like retype their message. Yes, that's how. Yes, so I had someone show me. I was like, I just want to see my grades in a way that makes sense. So is our test going to be mostly on
The chemistry.
and chemistry
Yep, volcanoes and chemistry. That's.
in the book?
I'm
No?
going to skip the book this test and put it on the third test.
Yes. Do that.
Hi, Sabrina, how are you doing?
Good. How are you?
Good. I'm going to wait on a few more people to get here.
Some people tried to show up on Monday.
And I didn't get a notification. I'm just going to tell you that now. So people probably don't think we have it.
Yes, very true. Because when you send out like that announcement.
The announcements?
Yeah, we don't get them unless our Blackboard app is working. That's the only reason I.
Oh my gosh.
I told you.
It would be better. I don't know if you have an option, but like, can you do like the Outlook email too? Because I always get the email.
Yes.
But I know some people don't even get the email, they just get Blackboard.
Yeah.
I never get
Okay.
Blackboard. I only knew we had classes. Someone texted me and said, "Did you get the Blackboard?" And I didn't. So
Yes, because that one day you canceled class and it was like
I was already.
snowing.
Yeah, I was already here.
The day it was snowing really bad. I was getting off the exit in Fairmont and I called Aaliyah and I was like, I'm driving here for one class. She said, you know, it's canceled, right? And I said, no.
Oh,
So
I see. I don't know that. I thought announcements went straight to your email.
No.
It did one time. You did it, and it went to the email.
So all right.
That's
So
when
then I have to click something to make
Yes.
it. That makes sense. I am so sorry. I did not realize that.
Yeah, that's what we said.
Hi. You guys will get lots of one-on-one time today. Hello, Abigail. How are you? Oh, she's on Zoom. For those of you at home, we have free periodic tables for you when you get here. And there is kind of a chintzy one online you can use. And also, let me share my screen with you on Zoom. All right. And so, those are my announcements that nobody got. Nice.
If I would have known you didn't know, I would have told you.
I thought we already told you.
You might have. I was on a lot of free medicine.
No, like before.
Oh, like
Shoot.
when I was telling you were going too fast. It was like that same day. I was like, I don't get your announcements.
Got it.
It was that day.
Okay. Well, I will try to remember to click that.
Do you want to stick to that?
Right there. Right there. All right. So. Those of you at home, let me open something up for you. All right. So in your homework folder, you're going to have The exact recipe matters, which is what we are doing today in class. And so most of this you'll get in class. And yeah, it'll be due next Wednesday, same day as your test. This test I'm going to be gentle with because of my absence, and it's hard to do chemistry on your own. So this is what we're going to be working with today, and it is found in Blackboard. And the other thing I've posted in Blackboard are common polyatomic ions. So today's notes are just going to be like, I don't have, this is a review of some things and some new things today. So there's not like an outline for notes. It's just, I'm going to have you take your notes. All right. So before we start that, I want to share something else. I want to review just some basic things. So starting back at volcanoes, the reason we look at chemistry is because we have 3 different types of magma. And tell me one type of magma we have. Very good, andesitic. And andesitic happens when you have oceanic crust, very, very dense, subducting underneath continental crust. So I'm going to do a new share real quick. We're going to share a whiteboard. Now, be careful. So we have andesitic. What kind of viscosity does andesitic have? We just keep on going. We'll go to Aaliyah. Okay, well, we only have 3 options. We have low viscosity, which means it's really running. We have high viscosity, which means, oh, it's going to blow up everything around it. And it's got medium viscosity, which means it's pretty dangerous, but it's not going to kill North America.
I think it's medium.
I think you're right. All right, this is medium viscosity. And skipping on over, come on up. I've got some stuff for you today. We're just doing a little review. Oh, well, we're going to catch you next.
I hate you.
That's very tiny magma. Hey. All right. So which this
Skip to that, 'cause that's all I
Yeah,
got.
I have
Yep.
Okay.
basaltic.
That's all I have.
All right.
I have hottest and the runniest, not a lot of pressure causing quiet eruptions.
Oh, you are good.
That's all I have too. I don't have the other kinds.
All right, basaltic, not balsamic. We have low viscosity, low heat. I'm sorry, that's a lie. High heat because it's very runny, but low amounts,
Pressure.
yep, caused by the SiO2, the quartz.
I did so good.
So low amounts of quartz, which means low amounts of stickiness. So yes, low pressure.
I have a question.
Yes.
So the last time I class, so 222, I put that we have both basaltic, AA, and Pahoe. Is that wrong?
No, those are all types of lava that are the result of basaltic magma.
So these are the results of it.
Yeah. So
Oh, that makes no sense.
that's okay. It's like the and the pahoe, like one is ropey and one is just like pahoe looks ropey. And the is just like
Wonky.
we got. All right. And then the last type of magma is the type that can wipe out portions of a continent when it erupts, and that is rhyolitic. This is what you have in like continental hotspots. Yellowstone Park is probably the most famous. That is nothing but rhyolitic magma because all it is a hotspot under a continent. So we have high viscosity. So it is the stickiest, if I can spell, the stickiest kind you get. High levels or high amounts of SiO2. That's what causes the stickiness, the viscosity. So what kind of heat? Very low heat. So it's the cool, now remember, it's still magma, so melted rock. But in relationship to everything else, the heat is pretty low. It only takes about 700 to 800 degrees to melt quartz. And that's the SiO2. So the more you have of it, the lower the heat is. So this is, the rhyolitic would cause like the most dangerous explosions, eruptions. And when we look at an eruption, a rhyolitic eruption, I want you to think about Yellowstone Park. It has 3 calderas. What's a caldera? Do we remember that? Maybe look at your notes.
Water is leaving a big hole.
Okay, the caldera is the big hole. So once the magma erupts, it becomes lava. Once the magma is emptied from that chamber, the ground just collapses. And that's what a caldera is. They usually fill with lakes. So at Yellowstone, they do have one of their calderas is partially filled with a giant lake. But the caldera is just that big impression after the magma chamber empties. And it usually fills up like a lake. Not always, but usually. All right. And of course, next Monday, we're going to play a big review game. Anybody at home have any questions about those 3 types of magma? So here I want to include, this is oceanic plates. Oops, oceanic. I forgot which one I put first. Oceanic to continental. So when you have those 2 combined, you get the andesitic. On the next one, it's when we have only oceanic plates. And this is a generalization. It doesn't always happen, but most of the time. And here, this is the result of a continental plate. You know, and all of these mean that they get melted. All right. So why are we even talking about this to kick off today's lab? Well, I want you to look at SiO2. So on your periodic table, stop. Okay. So, that's not what I want either. All right, so on your periodic table, I want you to find silica, or silicon, sorry. What is the atomic number of silicon? All right, so 14, and then what is the atomic number of oxygen? Are those two elements close together? Yep. So yes. Nod your head, yes. Yes, they are. They're very close together. That usually means if you think back to biosphere, I know we're having a hard time thinking back to February, but if you think back to biosphere, you should have done something called electronegativity tables, where you looked at ionic, covalent bonds and polar covalent bonds. But we're just going to concentrate. Yeah. So let me give you the easy version. If they're close together, most likely they're covalent. If they're far apart from each other, they're ionic. Okay? So if you trust me, that works about 85% of the time. And on your test, it'll work 100% of the time. Far apart, like if you've got this pink in between your elements, if you've got this pink in between your elements, that's going to be ionic bond. It'll produce a salt. If you do not have pink in between your elements, and they're close together over here, or they're the exact same element being bonded. Let's say, anybody have a diamond on? Like a diamond, that's covalent bond. It can either bond to itself, or it bonds to an element close, very close together on the periodic table. The only time this doesn't really work is if you look at hydrogen and you ignore the color green, you're going to think, oh, look, hydrogen is far away from oxygen. I bet it's ionic. No, that's not right. So this little green comes over here and it's this color green. That makes hydrogen and oxygen actually covalently bonded. And we're going to practice these things today with numbers.
So we don't go by the atomic number. Like 3 is over here with lithium, and then 2 is helium, but they're on opposite sides. So even though that they're 2 and 3.
Exactly. You look at their physical distance. Yes. The only time you would use numbers to get the bonds is the electronegativity numbers, which I did not provide you. So we're just going to look at the physical distance on the periodic table. Pay attention to the colors with helium. No, with hydrogen. Pay attention to that color. All right. So, does everybody have a copy of the exact recipe matters? All right, I want you to get that out, and we are going to be working together. So if you're afraid of your partner, just mask up and stay away from them. If you're not afraid of your partner, scoot over. So find a partner, because I don't want you to like feel left out. So somebody adopt that pretty little girl in the back. Lacey, you can move over. You can work with them. You can work with her. You can work in pairs. You can work as a whole class. I don't care. All right. So this isn't really a quiz. It's kind of like, okay, let's talk about this. So what elements are we going to find in the following? And I know it says don't use symbols, but I don't care if you use symbols. And before I go any farther, because I'm afraid I'll forget it by the end of class, go to the pedagogy connection and just X that out, because that's another one that hasn't been updated since I left in 2012. So there aren't the next generation science standards. So we're not going to be working on that. I'll cover it when you guys get me in methods, it'll be fine. So let's look at the elements in 1 drop of water. And I will do this with you. So I'm going to clear this. And so in 1 drop of water, what do we have? What do we have? What is H? All right, so we have hydrogen and Thank you. So those are the elements in water. We got that. A crystal of rock salt. If you know what salt is. Good. Sodium and what? Do you know the Na? Nobody? Yes, I heard it. Yeah, so what is Cl? Very good. Yay. So sodium what? Where's Cl? All right. So it's sodium and chlorine. Yum. Why does it taste so good? All right. So it tastes really good on the pork chop anyway. All right, a pile of sugar. Think back to biosphere. Actually, I don't know. Surely you had photosynthesis in biosphere. I'm thinking that that's where it would be covered, or high school or middle school. She's looking at me like plants. No. So sun comes in, works in those chloroplasts, and the plant produces oxygen, but that's not what I'm talking about. Glucose. What is the formula for glucose? C6, H12, O6. You're killing me, kids. All right. Good. So we've got carbon, we've got hydrogen, and we've got oxygen. Good. So the oxygen absorbed by your lungs. We got oxygen, yes. Actually, oxygen always comes in pairs. But so if we were using symbols, you would have O2. And they always, like little kids on the playground, they always holding hands. A chunk of quartz. Now remember, this is the same thing that makes magma sticky. So what is that formula? SiO2. So what are our elements? All right, lots of oxygen. Oh, a nugget of gold. Don't I wish? Yeah, exactly. The only element in gold is gold. What is the, if we were using symbols, what is the symbol for gold? That's silver. It is AU. Dawson, you came in second place. All right. Now, you may think that if we look at elements, molecules, salts, and compounds, that seems like, oh, that should be easy. But no, it's not exactly as easy as we might think. So let's go through the difference between all of those things. So what is an element? Okay, it's the stuff on the periodic table.
Like all by itself?
Yes, an element, just like she said, all by itself. It's the smallest unit that contains the characteristics of whatever it is. All right. It contains the characteristics. So if it's hydrogen, it's just one little atom of hydrogen, and it contains the characteristics of that thing, you know, the scientific word for it. All right, so that's an element. What's a molecule? Excuse me. What's a molecule? So I know that we all know what water is, H2O. But a molecule has to be covalently bonded. It has to be covalently bonded. So like I said before, with the H being green and it's actually closer to the oxygen than you think, it's covalent. It is the opposite, not really the opposite, but it's different from salts. Salts are ionically bonded. So yeah, table salt. Okay, that's an ionic bond. But so is, let me find my periodic table. So is something like lithium chloride, right? It's not table salt, but it's still considered a salt. Or let's see, magnesium bromide. They're still far apart from each other, so they're ionically bonded. They're considered salts. So anything that has an ionic bond, I'm sure that's not spelled right. Ionically bonded. Anyway, you get it. It's an ionic bond, just in case I spelled that completely wrong. The longer I look at it, the worse it looks. How about a compound? Compounds are easy. They're pretty much exactly what they sound like. They are any two elements or the same element bonded together. So water is a compound. Salt is a compound. Has to have two or more elements bonded together. So what I want you to do is work with your partners. And let me stop this sharing. And we are going to go over what are the elements, which ones are molecules, which ones are salts, and which ones are compounds. So just looking at A, B, C, D, E, and F, put those on that table. So if I look, let me start at the very bottom with gold. So is gold an element? Yep. It's definitely an element. Is it a molecule? Can you have a molecule of gold? Yeah, because it's bonded to itself. So that means it's covalently bonded. So yeah, you could have a molecule of gold. It's not a salt because it's not. And is it a compound? Does it have two or more elements bonded together? Or is it just itself? All right, so usually we don't refer to that as a compound. But I will double check to see if compounds include that. So you guys go ahead and just work on that table right there.
So
Yeah, it has to be 2 or more different elements. All right, so those of you at home, Sabrina and Abigail, did you see where to download the lab that we're working on?
Yeah, I have it up.
Okay,
Yeah.
all right, good.
Do we just submit it to you
Yeah,
sometime
by
today?
next Wednesday.
Oh, not till next Wednesday.
Right, I just wanted to go over it with you guys today because it isn't something that is just intuitive. This is something that we really need to go through together.
Okay, thank you.
Uh-huh. All right. So did you find any overlaps? Absolutely. Yeah, there are some things that overlap. The only things that will not overlap are molecules and salts. You can't have it both ways. You're either a molecule or you're a salt. But everything has elements. If there's more than one element, we don't consider it an element. It's either a molecule or a salt. And anything that has 2 or more different elements in it is considered a compound. So number 3, if you add another atom of oxygen to water, what are you going to have? Exactly, you're going to have hydrogen peroxide, H2O2. Because remember, in a molecule, that's the smallest form of a substance that retains the property of that substance. So H2O retains the properties of water. If you add another oxygen to it, you have completely changed the molecule. Water you can drink, hydrogen peroxide you cannot. All right. So I'm going to help you label this periodic table. You're going to need a pen. The way, let me see if I can find real quick, something called oxidation numbers. And that way I can just share it with you. No, of course not. Oh, there it is. There it is. There it is. So we are going to use, I promise you, if you can add and subtract positive and negative numbers, you can do this. This is not anything that requires big, tough math. Let me just open this image. All right. Okay. So on your periodic table, the first column from hydrogen straight down, that first column gets the number +1. So feel free to write your oxidation numbers on here. In fact, I highly encourage it because you can bring this to your test. So it's going to require a pen. Yeah.
That first one is +1.
Yes. So the hydrogen family gets +1. So hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. They are all +1s. And I'll go over what that means in just a minute. So beryllium family. So the column, the yellow column that starts with beryllium, Be, they get +2. We are going to skip D block elements. We're going to skip the pink section. So when you see pink, ignore it. That is going to be higher than your pay grade. That's once you actually teach some chemistry, that's, you'd have to go back to that. We're not. So start with boron. It is also +3. Carbon is the last one that's positive, and it's a +4. Then starting with nitrogen, we go to a -3. The oxygen family is -2, and the fluorine family is -1. Helium, neon, argon, krypton, xenon, and radon are all part of the noble gas family, which means their outer shell is completely filled. They don't need to gain or lose electrons. They are stable. What these numbers mean is that, hey, I've got one extra electron in my outer shell. I can share it with you. I've got 2 extra electrons I can share with you. Well, if you're in need of 2 extra electrons, you're in luck. Or if you're in need of 1 or 3. So this is what it takes for oxygen to fill up that outer shell and be stable. It would need 2 more electrons. So hydrogen has what? +1. So how many hydrogens does it take to make water a stable molecule? 2. We know that because oxygen needs 2. So it's going to take 2 of those hydrogens to hook up with 1 oxygen to make it stable. When we look at these numbers, what we are looking at is the outermost shell of an electron, the valence shell. So you're going to bear with me when I draw this. Let's look at carbon, okay? This is my nucleus of carbon. How many protons does carbon have? Protons? 6, because the atomic number is 6. So it's going to have 6 protons. 6. Whoa. Protons. And since the atomic mass is 12, well, the mass number, if we round it, it's going to be 12. So 6 protons plus how many neutrons is going to give us 12? This was some of your other homework. So that's where we get the mass. That's how heavy that atom is. It's 12 atomic mass units. So that's what carbon is. If you look at the very bottom of carbon, we've got 12. We'll get back to why we're doing this. Yes. All right, so the first shell holds how many electrons? 2. So we have 1, 2. How many more do we need? Because remember, your protons have to equal your electrons. So we need 4 more. And I always, of course, I teach at a Catholic high school. So I always tell the kid, you can't pair up your electrons until they have one at a time. I said, so, you know, go up, down, left, right. I was like, remember that. So we go up, down, and it doesn't matter if it's left or right. So before we ever started joining them up, you have to put them by themselves. And that's like one of the rules in chemistry that we don't have to know, but you just have to know that, yes, they have to go by themselves before they come in pairs. So do we have 6 electrons? Okay. How many are in the valence shell? Valence, fancy chemistry word for the outermost ring. So here's my ring. How many valence electrons are there? 1, 2, 3, 4. There's 4 in the outer shell. Also the valence shell. Well, why does that matter? Because, we'll get back here. 4, new share. If we go back to those numbers we just wrote down, how many electrons does it have extra to give away? 4. That's where that comes from. So if we drew the outer shell of all of these, it would all have 4 in the outermost shell, 4 valence electrons. They're happy to give them away to get stable. Starting with nitrogen, they're wanting, hey, I want 3 negatives to become stable. I want 2 negatives to become stable. I want 1 negative. And those negatives are, of course, your electrons. All right. So let's go back to our lovely work. We are not going to do the cutouts. We're going to do the math. And I promise you, if you knew how long it took to do the cutouts, you would be like, oh, thank you for math. But all this is figuring out with those numbers how to fill in this table. So use, what is sodium? It is, and what is its oxidation number? Okay, so it is +1, good. And then you go potassium. Because hydrogen only has 1 electron in its outermost shell.
So we do anything for sodium.
Sodium is also going to be +1.
You write that right beside
Yeah, that's
you
not bad.
on the symbol.
Like the symbol.
Yeah. I'm so sorry. Let me go back and do a different share. Let me do that together with you first. Let me clear that mess. All right. So when I write sodium, I would write an A, and I do not have to, you don't have to, sometimes you will see it like that. You can just write the symbol and you're fine. Because over here at the charge, you're going to, whoops, sorry about that. Over here at the charge, you're just going to write +1. And potassium, same thing. Lithium, same thing. Then let's go to calcium. Calcium, sometimes you'll see it with 2 pluses, but I promise, like, don't worry about that. Just write the symbol for it and then the charge, which is +2. So simply use your oxidation number chart or the, what you've written down to go through and do that. And I am recording this so that I'll put that up in your lecture notes. That way, if you need to go back and listen to any of this stuff. Just let me know when you're done with that table. It shouldn't take long, but anybody need another minute? We good? All right, good. We are going to skip the cutout portion. We are heading to number 5. And I know it says call your instructor over to verify your results. We're just going to do these together. Where it says sodium and chlorine. So sodium has a charge of what? +1, and chlorine has a charge of what? So we can just put them right together. So just do NaCl.
So just write it next to A.
Yes, just NaCl. Yep, you're just going to write that next to A. If you can. So that's on the handout that you guys have on Blackboard. Then calcium and oxygen. We have calcium as what? In oxygen. Okay, again, now we can just do CaO, calcium oxide. But now we have barium with a charge of what? And fluorine is a charge of what? All right, so how many fluorine are we going to have to put onto the barium to make it even out? All right, so, and we write that with a subscript. So we're going to write, what was it, barium fluoride? All right, Ba, oops, it's hard to draw with this. So your 2 is your subscript. It tells me how many fluorine go with that barium. Subscripts only apply to the element that they come after. They don't apply to the element that they're not attached to. And then, well, this one's a little bit trickier. Aluminum oxide. So what's your charge on aluminum? Was it +3? And oxygen is your -2. So we got to do a little, I'm going to show you a little trick that always works. Always and forever. In order for you to make it even, I just take the charges, switch them, and drop them down and make them subscripts. So let me see what I'm on. My aluminum has a charge of what? Okay, so I'm going to take that 3, put it over here at the bottom. And my oxygen has a charge of -2. I'm going to put that at the bottom. So with aluminum having a charge of 3, 2 times 3 is 6. Oxygen has a charge of 2. 3 times 2 is 6. So yeah, that works out. Here's the thing, it works out every single time. You don't even have to do the math. you find those charges, and if they're not equal, you just switch them, drop them. That's all you do. That saved me a lot of heartache in my college chemistry class, especially on the things that I couldn't quite get to even out. So we are almost out of our time. Let me see. You skip over. I want you to just put an X through when atoms attract. Put an X through that. 1, 2, 3, and 4. Just get rid of it. Rules for writing compounds. I will put those rules up for you in your notes. That's not a problem. You have a handout of common polyatomic ions. And those of you at home, there's a place to download this sheet. Polyatomic ions come as a group that only have one charge. So it looks like a mess. It only has a single charge. And the ones I want you to circle that we are going to use a lot of are phosphate. So find phosphate, PO4, and circle that. And it has a charge of -3. So you just circle the whole thing or highlight it, however it makes you pay attention to it. And
Is that what you want us to write?
no, you don't have to, no, I just want you to circle this. I will give you the notes for the other thing. Hydroxide, that's easy, it's OH, and it has a charge of -1. Nitrate, and that's the NO3. It also has a charge of -1, so you see 1 negative, that just means -1. And sulfate, which is SO4, and trust me, you can bring this to your test too. You do not have to memorize polyatomic ions. That's ridiculous. And it has a charge of -2. So you'll be using that to finish this. If you have any questions whatsoever, bring this with you to class. When we meet again on Monday, we are meeting again on Monday, pass the word. And we will finish anything that you have to ask about this. We'll play games to get ready for the test. There is no book on this test. I'm saving that for our third test. Really, our third test and then will be very big and not very far away. All right, guys, anybody at home have questions?
I'm a little overwhelmed. So our test is still Wednesday and we're reviewing Monday.
Yeah, like next Wednesday.
Okay, so a week from today. So what I printed off, I feel like isn't right. The exact recipe matters.
Yes, that's what we worked on today.
Okay, so that is right. Okay.
Yes, and when you come in on Monday, Abigail, just bring the lab with you and we can go over it. Anything you guys are like, oh my gosh, I got home and I don't know what to do, bring it back. Bring it back.
Professor McKee,
Yeah.
Okay.
I am observing in this next week and they have spring break. And my only time to do that is on Monday. Can I come at the 1 o'clock
Yeah.
class?
Absolutely. That's no problem. All right, guys, I am going to exit out of this meeting, but I'm going to post it later so you can go back to it. It's
Okay.
be nervous because I always sound like a mess.
Actually,
But-
it's the week after. It's not next week, it's the 29th.
Oh, then definitely that's no problem. All right, guys, have a good day.
Thank you. Hey, I think the first couple minutes of class, I forgot to mute. I'm sorry.
That's okay,
Could
Abigail.
you hear my kid?
It's okay. Like, seriously, we were just getting ready and stuff.
Okay, I was like, oh no. Hey, how are you feeling?
Great. Thank you very much.
She can't see you. Say hi. Hi. I hope you feel better.
Thank you. You guys have a good day.